Hi everyone. Hope you are doing good. Okay, today we're gonna see how the applications are getting deployed and what kind of different strategies we are using it. So they're mainly monolithic, microservices, and serverless. We're gonna see what are the benefits and advantages and what are the drawbacks. We're gonna get it from each of the every strategies. First, we will move on to the monolithic. Okay, what is monolithic? Mono means single, lithic means rock, so it's a single rock. So this is a simple monolithic architecture, okay, where the users, which is client, they are trying to connect to the e-commerce. Let's give an example as Flipkart and Amazon. So there's a load balancer in front, but here all services like shop UPI, catalog services, and other services are hosted on a single server, okay, and they are getting that backend. It's acting as an data store, relation database management service. From there they're getting the details and they're just giving to the end user. If the whole server goes down, the application will not work, okay. That's a big drawback for the monolithic architecture. Here we're gonna see what are the benefits and disadvantages on this monolithic architecture. First, we're gonna see reliability. Okay, single point of failure. So why we are saying single point of failure? Let's consider your application is hosted on AWS. Okay, here the users are trying to connect to your application. There's a cloud front in between for content delivery to manage your workload and give it in the less latency. Here, your front end application, which is EC2 instance, it got crashed, it got down. So the entire application will not gonna function. So that's why we are gonna say single point of failure. If process crashes, the entire app goes down. Scalability. In scalability, there are two types of scalability is there. One is vertical, another one is horizontal. Let's give an example. Our application, there are 10 users logging in, and after that 10,000 users, and after that 10 lakh users. Because your application gain popularity, what we're gonna do is we're gonna scale it vertically from 4 GB RAM to 16 GB RAM, from 2 CPUs to 8 CPUs. Yeah, this is good, but let's consider if the whole server went down, even if you increase to another GP, okay, that is not gonna benefit, right? The application will not work. Okay, let's do horizontal scaling by adding up of another server. So we are adding one more server, three more servers, but consider this: if one operating system is running, it will consume the CPU RAM, okay, and other attributes within it. So cost will be a major problem in this. We have to use load balancer on a horizontal plot auto scaling in order to scale horizontally. That's why not feasible to scale horizontally. Okay, let's next one is response time. Response time is very low. Why? Because every services is running on the single server, which is no, there won't be any IP address change. They're gonna use the SAD resources, so the response time is very less. Okay, next we will move on to the development experience. Hope you are a developer. You are working on a monolithic architecture. It is easy way to run and test it locally. Why? Because we're gonna use a single repository. Within the single repository, all services will be categorized. So fast way to build, test, and deploy. Okay, next one is cost. So if you want a server that will be running on a certain amount of time, either we can rent a virtual machine, or maybe the pricing will be fixed, because we can go with savings plan or else on demand instance based on the use case. But you're purchasing a instance which have 10 vCPUs, okay, but only you are using 2 vCPUs at the time of less workload, and at the time of high workload you are using 8 vCPUs, but anyhow you're gonna pay for 10 vCPUs. That's why the cost will be a drawback on monolithic architecture. Okay, let's move on to the next one, which is a game changer, which is microservice. Okay, what is microservices? Micro means small, services means it does something, right? What architecture? Let's give a simple architecture which is hosted on AWS, where the users are trying to connect to their application. We have a API gateway. The API gateway does the correct domain mapping, and in with the help of the APC link, we have an application load balancer. This will distribute the traffic to the clusters where the containers will run. Within the container, microservices pod will be running it, and each microservices will can have a separate databases. Okay, so if one thing goes down, another one we get affected, and they are getting the docker images from the ECR. Okay, here I'm gonna show you how not gonna affect another service. So the request is coming from the user, and it is going to the service 2, but the service 2 is not working due to some crash loop or some other reason. Okay, only the service 2 will not gonna work, but partially your application will function. Why? Because service 3 and service 4 are functionable. So that's why microservices is a good way to go. Okay, now we're gonna see the benefits and drawbacks on microservices as well. The development experience, strong boundaries, which means each and every developer will have their code repository one, and microservices one, rather than of working on the same repository which have all microservices. Each developer can work on separate code repository specific to the microservices. So it's a big advantages, but they have to move from one repository to another repository and make changes. It's hard, but that's how it has to work on microservices. Okay, scalability. So scalability in the sense, monolithic we can scale at horizontally and vertically within the specific server itself, but here we can increase uh, pod request and limit. Okay, vertical scaling is it can be done. Horizontal scaling, we can add up replicas. Okay, adding up of another pod specific to the microservices. So it's very good. Microservices is known for their scalability. Response time, here the response time on microservices, it's little bit drag. Why? Because internal communication has to happen from one microservices to another microservices, where serialization and deserialization will happen. And if you have high amount of large payloads that has to communicate it with within our microservices, there will be a response time will be there is some delay will be there. So response time is a drawback. Next one is reliability. So failure isolated per services, apps still partially functionable. As I mentioned on this, even one services goes down, other services will be available. That's the advantages. If you just on the cost will be higher. Why? Because when you want to run a cluster like EKS or Red Hat OpenShift, you need a master node, infra node, worker node. So the cost for running this kind of architecture will involve additional charges, because we are getting some benefits from it. So that's why the cost is high. And pin packing issue. What is pin packing issue means? It's nothing but we have gotten server for 10 vCPUs and 10 GB of RAM, but the microservices only gonna use 2 CPUs and 2 GB of RAM, which means we are not utilizing it up to the mark. Only if the pod gets increases, the utilization will spin up. So there is a pin packing issues is there. Okay, that's why the cost is a drawback in this microservices. Next, we're gonna see the difference. Okay, a monolithic tightly coupled functions, microservices is loosely coupled function. No fault isolation. Fault isolation is there. Scale entire application. Selectively scale specific to the microservices. Single code base. Okay, code base specific to the microservices where we can allow different repository to the different servers. Common language tools DB. Choice of language tools DB per services. Large integrated development teams should be there, but in microservices specific to the services we can allot a specific development team, so focused on the specific microservices. Centralized data management, decentralized data management. Okay, and release entire application, release per service. So if you want to do one release on monolithic, you want to release the entire application itself. Okay, but here you're gonna trigger a pipeline specific to the microservices and only gonna change that per service itself, because we have separate code repositories, separate pods that running on the worker nodes. As you mentioned, this is the overview on the picture view how the code cell one is tightly coupled on monolithic, and here the monolithic is acts as a single building where all front end back end database will stores on a single building, whereas microservices each and every building is small based on the use cases, customer support, user interface, platform, framework. Okay, next we're gonna see serverless. Okay, serverless will be the main advantages going forward. Everyone will can move to serverless, but this also has some benefits and drawbacks. We're gonna see that this is a basic architecture of serverless where the client, which is our user, let's give an example. I'm trying to log into a app which is Instagram. So Amazon Cognito will do the authentication, and it will send to the CloudFront, and CloudFront will check if there's static objects that will be stored on S3 bucket. It will get the result, and CloudFront will be mapped to the API gateway, and API gateway will there to the AWS Lambda. There will be no load balancer in between. That's the advantage of serverless. This AWS Lambda function takes care of everything. You don't need to define any kind of stuffs. This function will take off the microservices, and all the CPUs and RAM, every infra part, this will be taking it. That's why we are calling it as serverless. Serverless doesn't mean there is no server. There is a server that is where the application is running, but we don't manage it. Okay, and it is getting the details from the DynamoDB because it's a NoSQL databases. Here we're gonna see the benefits and drawback. First, development experience. It's a simplest coding model. No infra management, so easy for the developers. Scalability is a big advantage over here, because from like if you want to use your application like 128 MB to 10 GB, it's possible. Even if you are not consuming anything, it's been 0 to infinite, also is possible. So that's why serverless is very good for scalability. But response time, some face cold starts, which means they may face 10 millisecond or up to 1 second at the time of starting application. But here also we can use some kind of services in order to less the response time. But as of now, is a drawback in the serverless architecture. So reliability, so failures are isolated per function. If one function it's getting affected, same as microservices, other function won't be affected, and we're not gonna manage the infra. Everything will be taken care by the services like Lambda itself. And the next one is cost. Cost is very much cheaper in serverless. We're gonna use what we pay for. If you're not using it, you're not gonna pay. Only on the based on the workloads of your application, the charges will occur. So that's why cost is a big advantage. And after checking all these things, we're not gonna consider each strategy is good for our application. Based on our application need, we're gonna choose it's suitable for monolithic, microservices, or serverless. So all kind of applications will run on different strategies, but we have to figure out which one will be the best use case for our application. Okay, thank you so much for watching the video so far. Bye bye.